Okay, folks, here's our last differential equation problem. It's the 2016 number 4 question. First thing you're going to notice is this is the last deliverance of the old AP, which was more based on content and a little less tricky. You're going to notice this problem is a lot more straightforward than the ones we've seen. I have a feeling that this is kind of how one of the problems is going to look on the test. This was originally a non-calculator problem. We'll do it both ways to make sure we can use our calculator effectively to solve the steps. And let's see what we have. Okay, so I'm going to bring the page over here so we can see it for a moment. It says consider the differential equation. dy dx equals y squared over x minus 1. I'm guessing they're going to ask me to do one of a couple things. They're either going to ask me to fill in the slope field or solve it or find a tangent line. And remember, if we hear tangent line, we're going right to our information on tangent line. So let's take a look at what we've got here. I'm just setting up a blank document while I'm doing that on the calculator. I've got a blank doc ready to go. It says on the axis below, sketch the slope field for the differential equation for the 6 points indicated. They're never going to give you more than 6 points. It's kind of how they set it up here. So what I've done over here is I've created a table of values. I've written in all the 6 points they have, 0, 0, 0, 1, 0, 2, 2, 0, 2, 1, 2, 2. And literally I'm going to take the numbers I have here and fill them into the slope field to find the slopes of each of those things. So the slope at 0, 0 is 0 over negative 1, which is 0. The slope at 0, 1 is going to be 1 squared over 0 minus 1. So the slope there is negative 1. The slope at 0, 2 is going to be 2. Here we go. 2 squared, which is 4, over 0 minus 1, which is negative 4. At 0, 2, 0, the y value is 0, so it goes on top. Doesn't matter what goes on bottom, I'm going to get 0. The next function is the point 2, 1, so it becomes 1 squared, which is 1, over 2 minus 1, which is 1. And the next one is at 2, 2, so the top becomes 4, 2 squared, over 2 minus 1, which is 4. You see I got those numbers there. I'm going to fill in the easy ones at first. I'm going to fill in 0, 0. The slope is 0. And I'm going to fill in the slope at 0, 2. Sorry, 2, 0. Get those in there. Now, I'm going to always do the slopes that are 1 and negative 1 next. It just makes life easier. So this is going to be 45 degrees up. And I know this one's negative 1, so it's going to be 45 degrees down. And then all I have to do is remember to make it more slopey or less slopey in the direction I'm going. Here, the slope is 4 negative. So it's going to be slopier than this, but down. So I'm going to go like that. And I'm going to do the same thing on this side. And that's enough for the 2 points on that problem right there. You can see it's a lot more straightforward than the ones in the old days. Let's take a look at the next part of the problem. The next part says they want us to find a particular solution to the differential equation, and they give us an initial condition of f of 2 equals 3. They're always going to give us one value to kind of start out with. The next part of the graph says find and write an equation for the line tangent to the graph at x equals 2. Stop reading the problem when you ask you to find a tangent line. They want me to find a tangent line. They want it at x equals 2. I'm going to fill it into my information of line equals, forget your derivative, your cross-country team, and forget you. I've already filled the numbers in there. I'll write the generic equation so you can have it. F prime of c, x minus c, and f of c. All I have to do is find those particular values. Well, f prime of 2 would be the derivative of 2, which is so first I have to find f prime of 2 at 3. So I've got to fill in 2 and 3 into the derivative right there. So I get y squared, that's your y, is 9 over 2 minus 1 squared is 1. So the slope is 9. I'll write it as 9 over 1 here. X minus 2, that's our x value, plus the value of f at 2 is 3. So I can leave it like that. That's the equation for my tangent line. Line equals 9, x minus 2, plus 3. So let's say you were doing this problem and had no clue where to get the slope from, the prime. Just make it up. Fill in the 2 and the 3 for x and y, and make the other part up. And then it asks you to use that line to estimate 2.1. Well, that would mean that the line at 2.1 is equal to 9, parentheses, 2.1 minus 2 plus 3, which equals, this is equal to 0.1. 0.1 times 9 is 0.9, so this becomes 3.9. Then the last part of the problem, which I figured was coming up, they asked me to solve for f of x at 2, 3. 2, 3 is our particular value. We're going to separate, integrate, and solve this differential. They're probably going to ask us to do this. We're going to check it with our calculator, but I'm going to do it the long way first. So my original equation is d squared y over dx equals y squared over x minus 1. I'm going to start by cross multiplying. Doesn't always help, but it usually makes it easier. X minus 1 dy equals y squared dx. And you can see already this problem's got problems. The x's are not by themselves. The y's are not by themselves. All I'm going to do is I'm going to move the y's first. So if it's y squared on this side, I can multiply both sides by y to the negative second, or just assume I'm moving this to the side. It becomes y to the negative 2 dy equals 1 over x minus 1 dx. I know I did that the quick way, and that's kind of how they want you to do it in calculus. If everything's multiplied, move it to the other side as a negative. If it's written like this, I will show you to move this thing with the step. I would multiply both sides by 1 over x minus 1. Just to get it to the green problem we have right there. Okay, this problem is now ready to integrate. I can now integrate both sides. I will solve that over here. So y goes up a degree, y to the negative 1. That number goes out front, equals the integral of 1 over something is ln of the absolute value of that something, plus c. And that's enough for the general solution. If you want to get y by itself, some people feel the need. I'll multiply both sides by negative y, by negative sign. And I will get y to the negative 1 equals negative ln x minus 1 plus c. You notice I didn't change it to a minus c. I can if I want to, but it's kind of like having, there's a c1 here, and there's another c in there. The minus sign just gets soaked on in. And to get rid of the minus 1 here, I'll put both sides to the minus 1 power. And I will end up with, I'll write it right here, y equals 1 over the negative ln of x minus 1 plus c. And I can leave it like that. I could have left it in either this original form right here, which is probably why I would have left it. I would have left it in this blue form right here, and then use that to find c. I'm going to pull that problem out. I'm going to grab it from here and bring it over here. If you feel the need to go this far, you can go that far. You don't have to. Then to find c, I fill in the values I have, which are 2 and 3. So it's going to be negative 3 to the negative first equals the ln, the absolute value of 2 minus 1 plus c. 3 to the negative 1 is 1/3. Negative 1/3 equals the ln of 1 is 0 plus c. So c equals negative 1/3. And that would have given me my equation right there. I'm going to write it up a little higher just so I can see the final answer. So negative y to the negative 1 equals ln, the absolute value of x plus, x minus 1, close parentheses, minus 1/3. I can leave the problem just like that. That would be the final answer there. Okay, really quickly, if I had my calculator, which I do have my calculator, there's a couple things we can do. Let me turn the calculator on, turn this screen off for a moment. Okay, what I could have done if I want to see the slope field, menu, analyze graph entry, differential equation. I could have plotted the slope field, which is y1 prime equals, make it a fraction. Make the fraction, it does work in there now. I would have put in y1 squared over x minus 1, hit enter. And that would show me what the slope field would look like. I could see the values that they made me find. They're on the graph there. You can kind of see them. They're not perfectly clear. But we don't use that much for slope field. What we're really going to use it for is solving differential equations, which is the following. I'm going to put in this differential equation under menu, calculus, differential equation solver. Because on the original test, they don't expect you to have it, but you will have it here to check. So I will go y prime. Pi is where the prime is. Prime equals, make a fraction, y squared. I don't need the y1 here because I'm using the regular calculator part. Over x minus 1, comma the independent variable x, comma the other variable y. Hit enter. And there's the solution to the differential equation. It may look a little different than what I have down, but it really isn't, because take a look. The negative sign has been moved over to the fraction part. I did it here. It looks like this one right here. They just put it up on the top, and they move the part down to the bottom, and then they just use that info to solve out the value for C. Okay, there's AP 2016, number 4. I think we've done enough differentials to know what's coming up. So in the upcoming videos, there are going to be a couple more related rates problems, or things the other type we're going to see. I'll keep sending the videos. Good luck.